Good afternoon. I am G. Shankar, working as lecturer in Computer Engineering Department in Government Polytechnic College, Pillaripattu, Chittoor district in Andhra Pradesh. So in this session, I am going to give lecture on deadlocks in operating system support. So deadlocks is a very important concept in operating system. So before going to discuss all the things, first I will give the brief explanation about the contents which we are going to discuss. That is, what is deadlock and what are the conditions for occurring deadlock? How we can describe a deadlock situation and how the deadlocks can be handled. That is, what are the methods for handling deadlocks? Coming to the first concept, what is deadlock? So in multi-programming environment, every process needs to complete its task. So to complete its task, every process requires a set of resources. So at that time, every process will request for a resource which may be assigned to other process. In the same way, the other process will request for the resource and that may be assigned to another process. So in that way, so every process will request for resource and it will enter into waiting state. So then there will not be a process for processing. So at that time, all the process will be in waiting state. So that situation is called deadlock. So mainly the deadlock will occur due to four conditions. They are mutual exclusion, hold and wait, no preemption, and circular wait. Coming to the first one, mutual exclusion means if a resource is assigned to a process, then no other process is allowed to access that resource. That is, sharing is not allowed. Coming to the next one, hold and wait. Every process will hold some set of resources and request for another set of resources. That is called holding and waiting for other resources. And coming to the next one, no preemption. It means once a resource is assigned to a process, the other process is not allowed to release the resource from that process. And last one is circular wait. Circular wait means if all the process which are there in the system are waiting for resources in circular manner, then the deadlock will occur. The circular wait is similar to hold and wait situation. If all these four conditions occur at the same time, then only the deadlock will occur. Next, coming to how we can describe a deadlock situation. So for describing a deadlock situation, here we can use resource allocation graph, where we use some set of symbols. That is, for process we use circles, for resources we use rectangles. If more than one resource is there, then we use dots in the rectangle based on the number of resources of same type. And next we use some lines for requesting edges and allocation edges. Requesting edge will be from a process to resource, whereas the allocation edge will be from resource to process. Okay. If process and resources are requesting edge and allocation edges are mentioned in the graph, then after seeing that path, complete path, if there are any circular path, means closed path, then we can say there is a deadlock. But this is also not possible in all the cases. If only one resource of each resource type, then if there is a closed path in the resource allocation graph, then only we can say that there is a deadlock. Whereas if multiple number of resources are there, even though there is a closed path, there is no, we cannot say that there is a deadlock guarantee. Next, coming to the next one, how can, thank you. So with this I will